Hello students, welcome to this lecture, One Straight Lines Theory. So in this lecture, we will cover NCERT section 9.2.2, 9.2.3 and example 1 to 3. So this is disclaimer. So in today's lecture, we will first discuss conditions for parallelism and perpendicularity of lines in terms of their slopes. Then we will discuss NCERT example 1, and then we will discuss about angle between two lines. Then we will discuss NCERT example 2, and at last we will discuss NCERT example 3. So students, first of all, make sure you have your notebooks and pens ready. So first here we discuss conditions for parallelism of lines in terms of their slopes. Okay, so in a coordinate plane, suppose that non-vertical lines L1 and L2 have slopes M1 and M2. Okay, so suppose we have two non-vertical lines with slope M1 and M2 respectively. So let their inclinations be alpha and beta. Okay, so first we let here inclination of the line L1 is alpha and the inclination of the line L2 is beta. So if the line L1 is parallel to L2, so see this figure 9.4. So here you can see lines L1 and L2 are parallel lines. Okay, so the slope of L1 is M1 and the slope of L2 is M2. Okay, and their inclinations are basically alpha and beta. So then their inclinations are equal. That means alpha is equal to beta. Okay, that is alpha is equal to here beta. So now it implies tan alpha equal to tan beta. Okay, so we have given here L1 line is parallel to the line L2. Okay, and their inclinations are equal. That means alpha is equal to beta. So it basically implies tan alpha equal to tan beta. So it implies M1 equal to M2. Why? Because we know slope of the line L1 is M1. Okay, and slope of the line L1 is M1 and M1 is basically equal to tan alpha, where alpha is inclination of the line L1. Okay, and the slope of the line L2 is M2. Okay, and M2 is basically equal to tan beta, since the inclination of the line L2 is beta here. Okay, so since we know slope formula, that is M equal to tan theta. Okay, so slope is nothing but a tangent of an angle theta, where theta is what? Theta is basically inclination of the line. So therefore their slopes are equal. So this is we first suppose L1 line is parallel to the line L2, and then we have shown here their slopes are equal. Okay, so now if their slopes are equal, so here first we suppose here slopes of the lines are equal, and then what we'll see, so we will show the lines are parallel. Okay, so first of all, let us take a look at this figure 9.4. So here, if the slope of two lines L1 and L2 is same, what does it mean? So that is mean M1 equal to M2. Okay, so if the if their slopes are equal, that is m1 equal to m2, then we can say tan alpha this is equal to tan beta. Okay, since we know m equal to tan theta. Okay, so we know m equal to tan theta, so we can write tan alpha equal to tan beta. Why? Because the inclination of the line L1 is alpha, so slope of the line L1 is tan alpha. Okay, and the inclination of the line L2 is beta, so slope of the line L2 is tan beta. Okay, and since we have if we have taken here slope of two lines L1 and L2 is same, so M1 equal to M2, it implies tan alpha is equal to tan beta. So by the property of tangent function between 0 degree to 180 degree. Okay, so between 0 degree and 180 degree. So the property of tangent function, that is if alpha this is equal to beta. Okay, so tan alpha equal to tan beta, this imply basically alpha equal to beta. Okay, so therefore there the lines are parallel. Okay, so hence two non-vertical lines L1 and L2 are parallel if and only if their slopes are equal. Okay, that is m1 equal to m2. So what is m1? So where m1 is slope of the line L1, and what is m2? So m2 is basically slope of the line L2. Okay, so we have shown here for two non-vertical lines L1 and L2. Okay, so two non-vertical lines L1 and L2 are parallel if and only if their slopes are equal. Okay, clear? I think it is clear to all of you. So now we will see perpendicularity of lines in terms of their slopes. Okay, so if the lines L1 and L2 are perpendicular, so we first here suppose the lines L1 and L2 are perpendicular. Okay, so here you can see in figure 9.5. Okay, so here you can see the line L1 and L2 are perpendicular lines here. So from here you get the angle beta. Okay, so beta is equal to basically alpha plus 90 degree, where alpha is basically inclination of the line L1 and beta is the inclination of the line L2. Okay, so beta this is equal to alpha plus 90 degree. Why? Because you can see here this angle is alpha, this angle is 90 degree. Okay, so then this angle will be 90 degree minus alpha. Okay, and 90 degree minus alpha and beta, they are basically supplementary angle, so beta will be 90 degree plus alpha. Okay, so beta this is equal to alpha plus 90 degree. So from here now if we take tangent function on both sides, then you will get tan beta this is equal to tan of alpha plus 90 degree. Okay, so tan beta this is equal to tan of alpha plus 90 degree. So since we know tan of 90 degree plus theta is minus cot theta. Okay, so we know this tan of 90 degree plus theta this is equal to minus cot theta. Okay, so tan of alpha plus 90 degree this is basically equal to minus cot alpha. Okay, and we know cot alpha this is equal to 1 by tan alpha. Okay, so cot alpha is basically reciprocal function, trigonometric function of tangent of alpha. So minus cot alpha this is equal to minus 1 by tan alpha. So therefore m2 this is equal to minus 1 by m1. So tan beta is basically m2. Okay, that is slope of the line L2 is tan beta. Okay, and the slope of the line L1 is tan alpha. So slope of the line L1 is m1 and the slope of the line L2 is m2. So therefore m2 this is equal to minus 1 by m1. Okay, and now if we cross multiply, then we get m1 times m2, this is equal to -1. That means product of slopes, this is equal to -1. Okay, so if the lines L1 and L2 are perpendicular, then m1 into m2, this is equal to -1. So if their slopes are negative reciprocals of each other, what does it mean? So if slope of the L1 is m1, okay, and the slope of the L2 is m2, okay. So if m1 into m2 is -1, then what will happen? So conversely, if m1 into m2 is -1, that is tan alpha into tan beta, this is equal to -1. Okay, so m1 into m2, this is equal to -1. That is tan alpha into tan beta, this is equal to -1 here. So then tan alpha, this is equal to minus cot beta. Okay, so from here, from this equation, you will get tan alpha, this is equal to -1 by tan beta. Okay, and you can write it as tan alpha, this is equal to minus cot beta. Okay, and since we know tan of beta plus 90 degree is minus cot beta. Okay, so minus cot beta can be written as tan of beta plus 90 degree. Okay, or tan of beta minus 90 degree. So therefore alpha and beta basically differ by 90 degree. Okay, so alpha and beta differ by 90 degree angle. So thus lines L1 and L2 are perpendicular to each other. Okay, so since alpha and beta differ by 90 degree, so the lines L1 and L2 are perpendicular to each other. So hence two non-vertical lines are perpendicular to each other if and only if their slopes are negative reciprocals of each other. Okay, that is m2 equal to -1 by m1. Okay, or m1 into m2, this is equal to -1. Okay, where m1 is what? So what is m1? So m1 is basically slope of the line L1 and m2 is slope of the line L2. Okay, so this happens for two non-vertical lines. Okay, so when our two non-vertical lines are perpendicular to each other, then their slopes are negative reciprocals of each other. Okay, and if their slopes are negative reciprocals of each other, then two non-vertical lines are perpendicular. Okay, so you should keep in your mind this statement. Two non-vertical lines are perpendicular to each other if and only if their slopes are negative reciprocals of each other. Okay, that means m1 into m2, this is equal to -1. Okay, when happen it, if two non-vertical lines are perpendicular, then m1 into m2 is -1, and if m1 into m2 is -1, then two non-vertical lines are perpendicular. Clear? I think it is clear to all of you. So now, here we will see one warning. Okay, so see, if one line is vertical, okay, so we know if we have a line which is vertical, then slope, okay, is undefined. Okay, and other line is horizontal, that case slope of that line is 0. Okay, so then in this specific scenario, m1 m2 m2 not equal to -1. Okay, you can see this figure. So in this figure here you can see L1 and L2, these two lines, okay, these two lines are perpendicular, but here you can see L1, this line is vertical line. Okay, and slope of the line L1 is undefined. Okay, and here you can see L2 line. Okay, so here L2 line is basically horizontal line. Okay, and the slope of the line L2 is 0. Okay, so in this case here you can see the product of the slopes L1 and L2 does not equal to -1. So note this point. So now let us take an example. Okay, so now we will discuss NCERT example 1. So here see this example. So in this example, we have to find the slope of the line passing through the points 3 comma minus 2 and minus 1 comma 4. Okay. So we have to find the slope of the line passing through the points 3 comma minus 2 and minus 1 comma 4. Okay. So students, first of all, think about this for a moment. How would you approach for this example? Okay. So let us see solution. So we need to find the slope of the line passing through the point 3 comma minus 2 and minus 1 comma 4. Okay. So we have to find slope of the line, which line is basically passing through the point 3 comma minus 2 and minus 1 comma 4 here. So using this formula, m equal to y2 minus y1 divided by x2 minus x1, of where x1 does not equal to x2. Okay. So x1 does not equal to x2. That case, we can use this formula m equal to y2 minus y1 divided by x2 minus x1. Okay. Where x1 y1 and x2 y2 are 2 points. Okay. And m is slope of the line. Clear? So we will now use this formula m equal to y2 minus y1 divided by x2 minus x1. When we can apply this formula, when we have given the line passing through the points, 2 points, okay, that case we can use this formula. So let here x1 comma y1, this is equal to 3 comma minus 2, okay, and x2 comma y2, this is given to us minus 1 comma 4. Okay. So putting this value in the above formula, m equal to y2 minus y1 divided by x2 minus x1. Then what we will get? So then we get m equal to 4 minus of minus 2 divided by minus 1 minus 3. Okay. So m equal to 4 minus of minus 2 divided by minus 1 minus 3. And now calculate it. So then we will get m, this is equal to 6 divided by minus 4. Okay, hence slope of the line passing through the points 3 comma minus 2 and minus 1 comma 4 is minus 3 comma 2. Okay, so hence slope that is represented by m is minus 3 by 2. Clear? So I think this example is clear to all of you. So now let us see another part of this example. Okay, example B. So here in this example, we have to find the slope of the line passing through the points 3 comma minus 2 and 7 comma minus 2. Okay. So this example is for this example is very simple example. Okay. So we have to find the slope of the line passing through the points 3 comma minus 2 and 7 comma minus 2. So students, first of all, think about this example for a moment and then think about how would you approach this example. Okay. So let us see solution now. So here we need to find the slope of the line passing through the points 3 comma minus 2 and 7 comma minus 2 here. Okay. So using this formula, m equal to y2 minus y1 divided by x2 minus x1, where x1 does not equal to x2. Okay, so we are now going to use the formula m equal to y2 minus y1 divided by x2 minus x1, where x1 does not equal to x2, where x1 and y1 and x2 comma y2 are 2 points. Okay, of the line. So an m is equal to the slope of the line here. So let here x1 comma y1, this is 3 comma minus 2, and x2 comma y2, this is 7 comma minus 2. Okay. So we have given here 2 points, 3 comma minus 2 and 7 comma minus 2. So now putting this value in our formula, okay, in our formula, m equal to y2 minus y1 divided by x2 minus x1, then what we will obtain? Then we obtain m equal to minus 2 minus of minus 2 divided by 7 minus 3. Okay. And then you will get m, this is equal to 0 over 4. And hence slope of the line passing through the points 3 comma minus 2 and 7 comma minus 2 is 0. Okay. So the slope of the line passing through the points 3 comma minus 2 and 7 comma minus 2 is basically 0. So now let us move to another part of this example, that is example C. Okay. So this example is also similar example. So in this example, we have to find the slope of the line passing through the points 3 comma minus 2 and 3 comma 4. So this example is for you. Okay. So this example is homework problem to all of you. So note this example and solve it. So now let us see this example. Okay, so example D. So in this example, we have to find the slope of the line making inclination of 60 degree with the positive direction of x-axis. Okay. So what informations are given in this example? So in this example, we have given inclination, okay, of the line is 60 degree and the positive with the positive direction x-axis. Okay, we have given this, and then what we have to do? Then we have to find the slope of the line. Okay, that line made inclination 60 degree with the positive direction of x-axis. So let us see solution. So here inclination of the line alpha is basically equal to 60 degree. Okay, so given to us inclination of the line alpha is equal to 60 degree, and using this formula m equal to tan theta. Okay, m equal to tan theta, where theta does not equal to 90 degree. Why? Because if we take theta is 90 degree, then tan 90 degree will be undefined. Okay, so for this we use when we use this formula. Okay, m equal to tan theta. That case we take always theta does not equal to 90 degree. And what is m here? And what is theta here? So here where m is slope of the line, okay, and theta is inclination of a line. So therefore slope of the line is m equal to tan 60 degree. Okay, and it is known that the value of tan 60 degree is root 3. Okay, so the slope of the line m is equal to root 3. So hence slope m, this is equal to root 3. Okay, so the slope of the line making inclination of 60 degree with the positive direction of x-axis is root 3. Okay, so and this is the final answer. So I hope it is clear to all of you. So this example is very simple example. Okay, directly we used the formula m equal to tan theta. Clear? So now we discuss angle between two lines. So suppose we have two lines, okay, L1 and L2. Okay, and then how to find angle between two lines? So if we have two lines L1 and L2, and these two lines are intersecting at some point, okay, and then we have to find angle between these two lines. Okay, so you can see this figure 9.6. So here L1 and L2, two lines make angle theta, okay, between them, and this angle is here phi. Phi is basically supplementary angle of theta here. So here first of all let L1 and L2 be two non-vertical lines. So note this point. Okay, we are taking basically two non-vertical lines. Why we are taking this? Because if we take one line is vertical, okay, and other line is horizontal, that is for vertical line, slope of the vertical line is not defined. Okay, so here first we take here L1 and L2, uh, two lines, two non-vertical lines, okay, with slopes M1 and M2. If alpha 1 and alpha 2 are the inclination of lines L1 and L2. Okay, so alpha 1 is basically inclination of the line L1, okay, with the positive with the with the direction of x-axis, okay, and alpha 2 is basically inclination of the line L2. Okay, so alpha 1 is inclination of the line L1 and alpha 2 is inclination of the line L2. Then slope of the line L1 is what? So what is the slope of the line L1? So the slope of the line L1, okay, that is denoted by here M1. Okay, so M1 is basically equal to tan alpha 1. Okay, and the slope of the line L2, that is denoted here M2. Okay, so M2 is basically equal to tan alpha 2. So we know that when two lines intersect each other, so they make two pairs of vertically opposite angles, okay, such that sum of any two adjacent angles is 180 degree. Okay, so note this point, okay, and focus on this statement. So we all know that when two lines intersect each other, then they make two pairs of vertically opposite angles, okay, such that sum of any two adjacent angles is 180 degree. Clear? So let here theta and phi be the adjacent angles between the lines L1 and L2. Okay, so theta is basically the adjacent angle. Theta and phi are basically adjacent angles between L1 and L2 lines. So then theta is what? So theta is basically alpha 2 minus alpha 1. Okay, so if we take subtraction of alpha 2 and alpha 1, then we obtain theta. Okay, so theta is basically alpha 2 minus alpha 1, where alpha 1 and alpha 2 not equal to 90 degree. Okay, why? Because if we take alpha 1 or alpha 2 is 90 degree, then in that case tangent of alpha 1 or tangent of alpha 2 not defined. Okay, so for this we take here alpha 1 comma alpha 2 is not equal to 90 degree. Okay, and theta here alpha 2 minus alpha 1. So therefore tan theta, this is equal to basically tan of alpha 2 minus alpha 1. Okay, so since theta is alpha 2 minus alpha 1, so tan theta, this is equal to tan of alpha 2 minus alpha 1 here. So now we have tan of a minus b, this is equal to tan a minus tan b divided by 1 plus tan a tan b. Okay, so it is known that tan of a minus b, this is equal to tan a minus tan b divided by 1 plus tan a tan b. Okay, so note this formula. So now we are going to apply this formula. So therefore tan theta, this is equal to what? So tan theta is basically equal to tan alpha 2 minus tan alpha 1 divided by 1 plus tan alpha 1 into tan alpha 2. Okay, since we have seen in our previous slide, tan theta is basically equal to tan of alpha 2 minus alpha 1. Okay, and here we use this formula tan of a minus b, this is equal to tan a minus tan b divided by 1 plus tan a tan b. Okay, so therefore tan theta, this is equal to tan alpha 2 minus tan alpha 1 divided by 1 plus tan alpha 1 into tan alpha 2. Clear? So since tan alpha 2, this is equal to m2, okay, and tan alpha 1, this is equal to m1. Okay, so now substituting the value of tan alpha 1 is equal to m1 and tan alpha 2 is equal to m2, then we will get tan theta, this is equal to m2 minus m1 divided by 1 plus m1 into m2. Okay, and here for defining this, here 1 plus m1 into m2 does not equal to 0. Okay, so 1 plus m1 into m2 should not equal to 0. Okay, since m equal to here tan theta. Okay. So see this figure. So here are the L1 and L2, these two lines, okay, intersecting at some point, and theta and phi are basically adjacent angle between L1 and L2 lines, okay, and alpha 1, alpha 2 are basically inclinations of the line L1 and L2. So from figure, we obtain here phi. This is basically equal to 180 degree minus theta. Okay, so theta and phi are basically adjacent angle. Okay, so phi, this angle is basically 180 degree minus theta angle. Okay, so that tan phi, this is equal to tan of 180 degree minus theta. And as we know that tan of 180 degree minus theta, this is equal to minus tan theta. Okay, so 180 degree minus theta is basically lies one second quadrant. Okay, and in second quadrant, tan function is negative. Okay, so tan of 180 degree minus theta, this is equal to minus tan theta. So we obtain here tan phi, this is equal to minus tan theta. And we got here tan theta, this is equal to m2 minus m1 divided by 1 plus m1 m2. Okay, where 1 plus m1 m2 does not equal to 0. Okay, so tan phi, this is equal to minus of m2 minus m1 divided by 1 plus m1 into m2, where 1 plus m1 into m2 does not equal to 0. So now there arise two cases. Okay, so there basically arises two cases. So case 1, if m2 minus m1 divided by 1 plus m1 into m2 is positive. Okay, so this is first case. So first case is if m2 minus m1 divided by 1 plus m1 into m2 is positive, then what will happen? Then tan theta will be positive. Okay, so if this is positive, then tan theta will be also positive, and then tan phi will be negative. Okay, so for this case, so m2 minus m1 divided by 1 plus m1 into m2 is positive, then tan theta will be positive and tan phi will be negative. Okay, note this point. So which means theta will be acute. Okay, acute means theta lies between 0 degree and 90 degree. Okay, so theta lies between 0 to 90 degree, and phi will be obtuse. That means phi is greater than 90 degree and less than 180 degree. Okay, so when tan theta will positive and tan phi will be negative, that case theta will be acute and phi will be obtuse. And now case 2. So if m2 minus m1 divided over 1 plus m1 into m2 is negative, then what will happen? So then tan theta will be negative and tan phi will be positive. Okay, so if m2 minus m1 divided by 1 plus m1 into m2 is negative, that case tan theta will be negative. Okay, note this point. And tan phi will be positive. So what does it mean? So which means that theta will be obtuse and phi will be acute. Okay, that means theta will be theta is greater than 0 and less, theta is less than 180 degree. Okay, and greater than 90 degree. Okay, theta will be obtuse and phi will be greater than 0 and less than 90 degree. Okay, so if m2 minus m1 divided by 1 plus m1 into m2 is negative, then tan theta will be negative and tan phi will be positive, and which means that theta will be obtuse angle and phi will be acute angle. So thus the acute angles say theta here. Okay, so between lines L1 and L2 with slopes m1 and m2, Okay, so the acute angle, say theta here, between lines L1 and L2 with slopes M1 and M2 respectively is given by tan theta. This is equal to modulus value of M2 minus M1 divided by 1 plus M1 into M2, where 1 plus M1 into M2 does not equal to 0. Okay, so we obtain here tangent of theta. Okay, tangent of theta, where theta is basically the acute angle between the lines L1 and L2. So tan theta, this is equal to modulus value of M2 minus M1 divided over 1 plus M1 into M2. Okay, and here 1 plus M1 into M2 does not equal to 0, where M1 is what? So M1 is basically slope of the line L1 and M2 is slope of the line L2. Okay, and theta is basically inclination between lines L1 and L2 here. The obtuse angle, say here phi, can be found by using phi. This is equal to 180 degree minus theta. Okay, clear? So tan theta, this is equal to m modulus value of m2 minus m1 divided over 1 plus m1 into m2, where 1 plus m1 into m2 does not equal to 0. Okay, so note this equation. Tan theta, this is equal to modulus value of m2 minus m1 divided by 1 plus m1 into m2. Okay, and from here you will obtain the angle theta between lines L1 and L2, that is tan inverse of modulus value of m2 minus m1 divided by 1 plus m1 into m2. Okay, clear? So now let us take an example. Okay, so here we now we will discuss NCERT example 2. Okay, so in this example, what informations are given? See this first. Okay, so if the angle between two lines is pi by 4, so what we have given here? So we have given here the angle between two lines, that is here pi over 4. Okay, and slope of one of the lines is 1 by 2. Slope of one of the lines is 1 by 2. Then find the slope of the other line. Clear? So basically we have given here angle between two lines. Okay, that is here pi over 4. Okay, and we have given slope of one of the line. Okay, that is here 1 by 2. And what we have to do here? So then we have to find the slope of the other line. So students, first of all, try it yourself. Okay, and then see solution. So you have 40 seconds to try to solve this example. Okay, and then we will provide the solution. Okay, so now let us see the solution. If the angle between two lines is pi over 4 and slope of the slope of one of the line is 1 by 2. Okay, then find the slope of the other line. So let us see solution. So we know that the acute angle theta between two lines with slopes m1 and m2 is given by tan theta. This is equal to modulus value of m2 minus m1 divided over 1 plus m1 into m2. Okay, so it is known that tan theta, this is equal to modulus value of m2 minus m1 divided by 1 plus m1 into m2, where m1 is slope of the line, one of the line. Okay, and m2 is slope of the other line. Okay, and theta is here and the acute angle between two lines. Clear? So we let here m1 is 1 by 2. Okay, and m2 is m, and theta is here pi over 4. So now putting this value in equation 1, okay, in 1, then we get tan pi over 4. This is equal to modulus value of m minus 1 by 2 divided over 1 plus 1 by 2 times m. Okay. So by putting the value of m1 is 1 by 2, m2 is m, and theta is pi by 4, then from formula tan theta is equal to modulus value of m2 minus m1 divided by 1 plus m1 into m2, we obtain here tan pi by 4. This is equal to modulus value of m minus 1 by 2 divided over 1 plus 1 by 2 times m. Or 1 equal to modulus value of m minus 1 by 2 divided by 1 plus 1 by 2 times m. Okay. Since we know the value of tan pi over 4 is 1. Okay. So we obtain this equation 1 equal to modulus value of m minus 1 by 2 divided by 1 plus 1 by 2 times m. So which gives us m minus 1 by 2 divided over 1 plus 1 by 2 times m. This is equal to 1, or m minus 1 by 2 divided by 1 plus 1 by 2 times m. This is equal to minus 1. Okay. So modulus value of m minus 1 by 2 divided by over 1 plus 1 by 2 times m equal to 1 gives us m minus 1 by 2 over 1 plus 1 by 2, 1 plus 1 by 2 times m. This is equal to 1, or m minus 1 by 2 divided over 1 plus 1 by 2 times m. This is equal to minus 1. So now case 1. So m minus 1 by 2 divided over 1 plus 1 by 2 times m. This is equal to 1. Okay, this is case 1. So if we take m minus 1 by 2 divided over 1 plus 1 by 2 times m is equal to 1, then what we have to do here? So we need to find here the value of m. Okay, that means we have to find the slope of the other line, that is here m. So for this, 1 multiply by 1 plus 1 by 2 times m in both sides of the above equation, m minus 1 by 2 over 1 plus 1 by 2 times m equal to 1. Then we obtain m minus 1 by 2. This is equal to 1 plus 1 by 2 times m. Okay. And now if we simplify it, okay, and if we calculate it, then we get m minus 1 by 2 times m. This is equal to 1 plus 1 by 2. So now from here you will get this 1 by 2 times m. This is equal to 3 by 2. Okay. And from this equation, you now get the value of m. So 1 multiplying by 2 in both sides, we get m equal to 3. Okay. So the value of m is equal to 3 here from case 1. And now case 2, m minus 1 by 2 divided over 1 plus 1 by 2 times m. This is equal to minus 1. Okay. So if we take the value of m minus 1 by 2 over 1 plus 1 by 2 times m equal to minus 1, then we have to find the value of m here. So here we need to find the value of m. So for this, 1 multiply by 1 plus 1 by 2 times m in both sides, we get m minus 1 by 2. This is equal to minus 1 minus 1 by 2 times m. So if the here angle is here pi by 4 and the slope of the one of the line is given 1 by 2, okay, and we have to find the slope of the other line. Okay, this is our target. So from that equation, we obtain here m plus 1 by 2 times m. This is equal to minus 1 plus 1 by 2. And after calculating, you will get 3 over 2 times m. This is equal to minus 1 by 2. And 1 multiplying by 2 in both sides in the above equation, we get m equal to minus 1 by 3. So therefore, we obtain here m equal to 3, okay, or m equal to minus 1 by 3. Okay. So the slope of the other line might be 3 or minus 1 by 3. Clear? And this is the final answer. So now we will now discuss NCERT example 3. So in this example, what we have given here. So here you can see line through the points minus 2, 6 and 4, 8 is perpendicular to the line through the points 8, 12 and x, 24. Okay, so what information given here? So we have given here one line that through the points -2, 6 and 4, 8, and this line is perpendicular to the line through the points 8, 12 and x, 24. Then we have to find the value of x. Okay, so we have to find here the value of x. Okay, so students, first of all, try it yourself and then see the solution. You have 40 seconds to try to solve this problem. Okay, and then we will provide the solution. Okay, students, your time is over. So now we will see the solution. So first of all, see what we have given. Okay, so try to understand this example. So we have given here line through the points -2, 6 and 4, 8. Okay, and this line is perpendicular to the line through the points 8, 12 and x, 24. Okay, and then we have to find the value of x. So let us see solution. So first of all, let here m1 be the slope of the line through the points -2, 6 and 4, 8. Okay, so we let here m1 be the slope of the line through the points -2, 6 and 4, 8. Okay, and using this formula, m equal to y2 minus y1 divided by x2 minus x1, where x1 does not equal to x2. Okay, where x1, y1 and x2, y2 are 2 point. Okay, and m is basically equal to slope of the line. So therefore, m1 is what? So what is the value of m1? So here, if we substituting the value of x1, y1, that is here -2, 6. Okay, and x2, y2, that is here x2, y2. Okay, then we will obtain the value of m1. This is equal to 8 minus 6 divided over 4 minus of 2. Okay, and this is equal to 2 over 6. Okay, and after calculating, you will get this is equal to 1 by 3. Okay, so the value of m1, this is equal to 1 by 3. So let m2 be the slope of the line through the points 8, 12 and x, 24. Okay, so m2 is here the slope of the line through the points 8, 12 and x, 24. So using this formula, m equal to y2 minus y1 divided by x2 minus x1, where x1 does not equal to x2. Okay, where x1, y1 and x2, y2 are 2 point. Okay, and m is the slope of the line. So we are going to use this formula, m equal to y2 minus y1 divided over x2 minus x1, where x1, y1 and x2, y2 are 2 point and m is slope of the line. So if we substituting the value of x1, y1, that is here 8, 12, okay, and x2, y2, that is here x, 24, okay, in our formula m equal to y2 minus y1 divided over x2 minus x1, then we will obtain the value of m2, that is here 24 minus 12 divided over x minus 8. Okay, and this is equal to 12 over x minus 8. And according to the question, two lines are perpendicular. Okay, and we have studied if two lines are perpendicular. Okay, if two non-vertical lines are perpendicular to each other, then product of their slopes, this is equal to -1. Okay, so here according to the question, two lines are here basically perpendicular to each other. So then product of the slope of the line line 1 and 2. Okay, so m1 into m2, this is equal to -1. So which gives us, so 1 by 3 times 12 over x minus 8. This is equal to 1 minus 1. Okay. Since m1 is 1 by 3. Okay. And m2 is 12 over x minus 8. So we obtain this equation 1 by 3 times 1 by 3 times 12 over x minus 8. This is equal to minus 1. So students, how can you now solve this equation? Okay. So how can you solve this equation? So we have here this equation 1 by 3 times 12 over x minus 8. This is equal to 1. So here we obtain this equation 4 equal to 8 minus x. Okay. Or 4 equal to 8 minus x. And from this equation, we obtain the value of x is 4. Okay. So there, hence the value of x is 4. So line through the points minus 2 comma 6 and 4 comma 8 is perpendicular to the line through the points 8 comma 12 and x comma 24. Then the value of x is 4. Okay. And this is the answer. Okay. This is the final answer for this example. Clear? So I think this example is clear to all of you. So that's all for today's lecture.